Hello and welcome back to the 5.2 notes. This is part 2. And I'm going to go through an example of how to calculate the left, right, and midpoint Riemann sums. And before I start doing that, I do want to talk a quick bit about what a Riemann sum is. A Riemann sum is when you approximate, so it's when you approximate the area under a curve by adding rectangles. Okay, adding rectangles. Okay, and so there's a few things that we need to do. The first step, okay, we've got a 3-step process here. So step 1 is calculate the width. Calculate the width of the rectangles, okay? And that's what we're going to call delta x, okay? And delta x is equal to, and I'm going to use the variables b minus a over n, okay? Where we have an interval, okay? An interval from a to b, and n is the number of rectangles, okay? And then we want to, in step 2, okay, step 2, we want to calculate the heights of the rectangles, okay? And so the height is determined by the y values on the graph. Okay? And then step 3 is we want to then add up the areas of the rectangles. Okay, so that's what we've got. Okay, this is a 3-step process. It's not too bad, but we do need to go through it and show you a couple of examples. So the first one I'm going to do is LRAM, and that's an acronym for left rectangle area method. Okay. And we also call it just the left-hand Riemann sum. But what this means is that we want to start on the left. So start on the left and move right. Okay? So then what I'm going to do is take a look at this at what we're trying to do. What we're trying to do is calculate the area under this curve, okay? And that's the function f of x equals 1 over x, between x equals 1 and x equals 5. Okay, so this is our interval. Okay, so I'm going to come in here and say that this is our interval. Okay, and we want to do this with 4 rectangles. Okay, so the first thing I want to do, step 1, is calculate delta x. So step 1 is find dx, calculate delta x. Okay, so delta x is equal to, and we want to use that formula that we had up here, b minus a over n. So we have to use our interval and the number of sides, which is what we're given here. So we want to do 5 minus 1 and then divide it by 4. So I'm going to do 5 minus 1 divided by 4, which gives me 4 over 4, which gives me 1. So delta x is equal to 1. Now what I'm going to do is come over here and kind of look at between 1 and 5 and kind of section this off into 4 equal rectangles. And so, you know, the nice thing is that my delta x, the width of each rectangle is 1. So I'm going to start at 1 and just kind of partition this off and realize that I've got, you know, a distance of 1, a distance of 1, distance of 1, distance of 1. So what I'm going to do is come over here, and I'm going to do, label that this is delta x equals 1, delta x equals 1, delta x equals 1, and delta x equals 1. Okay, now, I want to start drawing my rectangles, and this is kind of the trickier part, just to kind of know what you're supposed to do. So my method, you know, if I'm doing LRAM, is to start on the left and move right. So let me show you what I mean by that. I'm going to come in here, and I'm going to draw a line going up at 1 until I reach my function, okay? And then once I reach my function, I'm going to draw a rectangle over to the right, okay? And then I'm going to draw a line down. Okay, same thing here. I'm going to go up to my function on the left side and then move right, okay? 1 unit and then down. Same thing here. Come over here, go up to my function at 3, and then go over to the right and then down. Same thing at 4, go to the right and then go down, okay? So now the big thing is, you know, we have these rectangles, but now we have step 2, okay? And step 2 is finding the heights, okay? And the heights are determined by the actual value of my function, okay? The height of this rectangle has the same value as the y value on my function at 1. Same thing here, the y value at 2, the y value at 3, the y value at 4. So the way to get those is to actually plug in these x values into our function and get those numbers. Okay, so I'm going to go ahead and just do that real quick. F of 1, okay, if I plug 1 into my function, I get 1 over 1, which is just 1, okay? If I plug in 2 into my function, f of 2, then that's going to be 1 divided by 2, so that's a half. Okay, if I plug in 3, f of 3 is equal to a third. And then f of 4 is equal to a fourth. And again, guys, I'm simply just plugging these numbers into my function and getting my y value, okay? So now, step 2, let's write these out. Okay, so I've got f of 1 is equal to 1, f of 2 is equal to a half, f of 3 is equal to a third, and then f of 4 is equal to 1/4, okay? So now, step 3, we want to add all these rectangles up, okay? And so let's take a look at this. Step 3, let me zoom in here. Okay, so step 3, okay, means I want to add up all my rectangles. So my area is equal to, okay, and I'm going to do this. I'm going to do delta x times f of 1, just for notation purposes, plus delta x times f of 2, okay, plus delta x times f of 3, plus delta x times f of 4. Okay, now, one of the things that we can do here is we can substitute our values in for delta x and our y values. So delta x is just equal to 1 on each of these, and I'm going to plug in my y values at each of these function values. So let's go ahead and let's write that our area is equal to 1 times 1 over 1, which is just 1, plus 1 times a half, plus 1 times a third, plus 1 times a fourth, okay? So then I get that my area is equal to 1 plus a half plus a third plus 1/4. Okay, and if I get a common denominator, then I'm going to get a common denominator of 12, so 12 over 12 plus 6 over 12 plus 4 over 12 plus 3 over 12. And if I add all those up, then my area is going to be 12 plus 16 is 18, plus 4 is 22, plus 3 is 25, so I get 25/12. Okay, and that as a decimal is going to give me about 2.083, okay? And now this is our approximation, okay? And the last thing I want to do is kind of label what we are doing, okay, the big purpose of it. And the purpose of what we're doing is to calculate the area, or approximate the area between 1 and 5 of 1 over x dx. Okay, This, when I use this integral notation, this is my exact area, okay? And we don't know how to calculate that yet, okay? But this is approximately, the exact area is approximately equal to 2.083, okay? We can get an approximation. We can get some value from that by doing one of these methods, LRAM, RRAM, or MRAM, okay? And so this is our LRAM approximation. Okay, and we're going to get a couple different ones. So let's go ahead and come down here and do RRAM. Now RRAM is we're going to do it on the same function, so we don't have to do all that work that we just, or not entirely all the work. But I do want to label what RRAM is. RRAM means we start on the right and move left. Okay. All right, so same thing, step one, we want to calculate delta x. So step one, we want to get delta x. And we've already done that with this function. We've already figured that out. Our interval goes from 1 to 5, and we want 4 rectangles. So our delta x is equal to 1. Okay, and then step two, we want to calculate the heights. Now, before I do that, let's come in here and let's partition this off from 1 to 5, and we want 4 equal spaces. So I'm going to come down here. Each of these spaces has a width of 1, so delta x equals 1, delta x equals 1, delta x equals 1, and delta x equals 1. Okay, now, in order to get my heights of the rectangles, we have to start on the right, go up to our function, and then move left. Okay? And we're going to start on the right, go up to our function, and then move left and draw a rectangle. Okay, same thing here. Go up to the function, move left, and then we go down, go up to our function, move left, and we go down. So now we've got these rectangles that we can add up, but we want to find the heights of them. Okay, now the height of the one on the far right is f of 5, so f of 5 is equal to a fifth, okay, and then all the other ones fall in place. So f of 4 is equal to a fourth, f of 3 is equal to a third, and then f of 2 is equal to a half. Okay, now we don't have f of 1, we don't have this rectangle here. So maybe you notice a pattern that, of this entire thing, we've got 5 different x values, but we're only using 4 of them. Okay, when we did LRAM, we used the 4 to the left, and if we use RRAM, we use 4 to the right. So sometimes you can pick this up and you can see the pattern, and it's not too terrible. But let's go ahead and write out these functions. So I've got f of 2 is equal to a half, f of 3 is equal to a third, f of 4 is equal to a fourth, and then f of 5 is equal to 1/5. Okay? So now step 3 is adding them all up. Okay, step 3 is add up our areas. So our area is equal to delta x times f of 2 plus delta x times f of 3 plus delta x times f of 4 plus delta x times f of 5, okay? So now let's substitute what we have in. I know delta x is 1 times a half plus 1 times a third plus 1 times a fourth plus 1 times a fifth. Okay, so then our area is then a half plus a third plus 1/4 plus 1/5. Okay, so then with a common denominator of 60, we get the fractions 30 over 60 plus 20 over 60 plus 15 over 60, and then plus, 12 over 60? Okay, so then our area is equal to, what do we got? 77 over 60, if we add all those up, over 60. And that's going to give us 1.283. Okay? Now, this is our approximation. Okay? And this is not the exact area. So this is an approximation. Okay, but what I do want to note here is that if we were to look at the exact area, okay, which is the integral between 1 and 5 of 1 over x dx, this will give us our exact area. Now, we don't know how to calculate this just yet, but this is exact, okay, exact area. And our exact area is approximately equal to 1.283. Okay, so what you notice here is that, in this situation, if we did LRAM on this function, we get an overestimate. If we do RRAM, we get an underestimate. Now what I want to do is I want to go through and do MRAM, and that's the midpoint Riemann sums, and that means that we use the midpoint. Okay, we want to use the midpoint to create our rectangles. Okay, and this one's a little bit trickier, a little bit more heavier on the computation, but the same process. Okay, so I want to do step 1, which is calculate delta x. We've already done that. That's going to be 1. Okay, we have an interval of 4 units between 1 and 5, and we want 4 rectangles, so delta x is 1. Okay, so now let's go through and let's partition this off. And so I've got from 1 to 2 to 3 to 4 to 5. So now I want to label all of my widths as delta x equals 1, delta x equals 1, delta x equals 1, and delta x equals 1. Now what I want to do is to draw my rectangles, okay? And so what I want to do is I want to find the midpoint between 1 and 2. And that's at 1.5, okay? It's right here, my midpoint. So what I do is I draw a line up until I reach my function, and then I put a point, and then I draw a rectangle, go to the left and to the right, and make a rectangle like this, okay? Same thing here. I go to 2.5. That's my midpoint between 2 and 3. I go up to my function, and I draw a line over and over and then down. Okay, go to 3.5, draw a line going up, and move to the right, move to the left, and then same thing at 4.5. Go up to our function, move to the right, move to the left, and make your rectangles. Okay, so now the nice thing about this one is that we can figure out that, we don't account for this area. We have an underestimate here, but we overestimate on this side. So we don't really do the average, but this gives us our best approximation. So, we don't get as much on this side, but we kind of notice that this area and this area are pretty darn close to each other. And so this gives us a really good, estimate or approximation. So what I want to do is I want to calculate now f of 1.5. So let me do 1.5. I want to do f of 2.5. I want to do f of 3.5, and then f of 4.5. Okay, those are my heights. All right, and so what I want to do in step 2, and I'm going to use my calculator and get some values for those. So we can figure out that f of 1.5 is equal to, and these are just the reciprocals of our fractions. You can plug these into your calculator. You can get some reciprocals. It doesn't really matter. But f of 1.5 is going to be 2/3. Okay. F of 2.5 is going to be f of 2.5 is going to give me 2/5. Okay, f of 3.5 is going to give me 2/7, and then f of 4.5 is going to give me 2/9. Okay, so now step 3 is to add them together. Okay, so step 3, add them up. So my area is equal to delta x times f of 1.5 plus delta x times f of 2.5. plus delta x times f of 3.5 plus delta x times f of 4.5. Okay, so let's plug our values in so we get an area of 1 times 2/3 plus 1 times 2/5 plus 1 times 2/7 plus 1 times 2/9. Okay, if I add all those up, all right, we just get 2/3 plus 2/5 plus 2/7 plus 2/9. And I'm going to go ahead and just plug that into my calculator. And so we end up getting, for an area, approximately 1.575 if we round to 3 decimal places. Okay, and this is an approximation. Okay? And so then, what we would say here, folks, is that, our exact area from 1 to 5 of 1 over x dx is approximately equal to 1.575. Okay? And this is an approximation. Okay? When I use this notation, when I write this, this means the exact area. Okay? But what we've found is we are approximating. Okay, we are approximating that exact area. Now, I will say this. Okay, if I actually do find the exact area, okay, the exact area, all right, if I evaluate that integral, my exact area is going to be 1.609. Okay, and so what you can see, okay, and this is the exact area, okay, I've calculated that because I know how to do it, you guys don't know how to do it, but what I want you to see is that, we have an overestimate, this is an underestimate, but if I do the midpoint one, that's going to give us a pretty darn close approximation, okay. I know this is a long video, I know that there's a lot going on, I hope that this is, informative. Please go ahead and get started on your homework and try this method out, the 3-step method. Okay, thank you. Bye.